What we are going to do now is to look at the hydrogen spectrum through a diffraction grating. We're not going to use diffraction glasses like it says in the instructions because they just don't work as well, and it's just not feasible for this lab. So we're going to do this the good way. We're going to use the diffraction grating. And so what you see here is the diffraction grating, which is the clear piece of glass that's atop that aluminum post. And it's scribed with lines that are very close together so that it breaks the light into its component wavelengths. And what you want to do here is to see what you see. And I'll explain that in a bit more as we zoom in. And what you'll see here is you see several wavelengths. Now you just want to look at the grouping in the center of the diffraction grating, because what happens is this repeats on either side. So just look at the central group. You will see several colors, right? I mean, the central group, what is that? That's the group of lines between the eye that are above the eye of replica through the line which is above the G of grading. You're just looking in that area above I through G. What colors do you see there? Okay. What colors do you see? Which one appears brightest? Now, if you want, you can go back and compare that brightness to what you saw when we looked at the spectra with the spectroscope, because the relative brightness of the lines are the same. Remember that the height of those lines through the spectroscope corresponds to the intensity of those lines. Okay? So the next part says, comment on the relative intensities of the various lines, which colors are brighter and which are fainter. How do those lines then compare to the lines that you saw with the ocean optics spectrometer? How are they the same and how are they different? Please be sure to answer each part of the lab report.